Hi, I wanted to quick do a introduction on how to do some finding area with a polar coordinate. I want to find the area in one loop here, one petal of this flower. Now, hopefully you've already looked at the reading and you know that to find the area we do 1/2 the integral of r squared d theta. Now, what makes finding area with polar coordinates tricky, but also maybe more interesting than some other things, is that the angle of interest is theta. Meaning, we're not doing x coordinates or y coordinates as our bounds. We're actually doing angles. So we have to find the angles that enclose our area, not the x and y coordinates. So it looks to me as though we kind of start here at 0, and it trucks around and then comes back to 0. Now, if you remember, r represents the distance away from the origin. Well, the point of interest here is the origin. So I need to know when r is 0. So I'm going to take my r equation, 4 sine of 3 theta, and set that equal to 0. Divide both sides by 4 sine of 3 theta equals 0. Well, you got to maybe think back here a little bit to Calc 1, to figure out when the sine of 3 theta is 0. I think the way we like to do it in Calc 1 is just kind of say, well, when would the sine of x be 0? Well, x would be 0, or pi, or 2 pi, or 3 pi, so on. Well, I only need 2 bounds, so I don't need to go any further than that. But what that means is that I need what's put in to sine to be equal to one of these 3 things, 0, pi, 2 pi, 3, or so on. So that must mean that 3 pi is equal to 0, 3 pi is equal, 3 theta is equal to 0, 3 theta is equal to pi, and you could keep going, but again, I only need the 2, I think, to get those bounds. So in this first equation, of course, dividing both sides by 3, that means that theta is 0. Here, theta is equal to pi over 3. So that seems to be my bounds. Now I regraphed this, and I think you're going to want to do that as you kind of get the hang of this. I regraphed this using my online graphing software with new bounds, because right now in the graph you're seeing the bounds are 0 to 2 pi. So let me show you the new graph from 0 to pi over 3. So here we are. This is and if you're ever looking for a way to graph these online, fooplot is very nice. So here we are from 0 to pi over 3. So now you can see it's only that one loop that we have. So my final integral would be 1/2 the integral from 0 to pi over 3 of 4 sine 3 theta squared d theta. And then you would use your calculator FNIT to solve that. Now if you're wondering, well, why didn't he just integrate from 0 to 2 pi and at the end divide by 3 because we only were doing one loop? I certainly could have. I just thought this was a nice way to get some practice on finding those bounds in an easy equation.